We know what you're thinking. What could be worse than an earthquake? Well, how about a megaquake? Because these earthquakes are so big, they don't just shake things up where they happen, but around the world. They're so powerful that their tremors can travel all the way through the Earth's core and pop back out on the other side. And then there's the giant tsunami waves they generate that can wipe coastal cities off the map. So let's talk about megaquakes, the global ripple effects no one saw coming. In 2014, an earthquake struck South Chile with a magnitude of 8.2. Now, this was a major earthquake by most accounts. It generated a small tsunami and caused between $6 and $9 billion in property damage. But its effects were felt as far away as Hawaii, thousands of kilometers across the Pacific Ocean. How did that happen? Well, due to something called seismic radiation. Seismic radiation happens when energy from an earthquake radiates outwards from the point of origin. At shallow depths, seismic waves move along Earth's surface like ripples spreading from the epicenter. These waves travel along the Earth's crust, which is made of several large and small plates that are always moving relative to each other. When seismic waves hit the edge of one of these plates, they get partially reflected and refracted. That means some get bounced back towards the source of the earthquake, while others get bent and redirected depending on the speed and density of the materials they move through. Now, seismic radiation doesn't just affect buildings and bridges, it affects everything on Earth's surface, including the water in our oceans. When seismic waves enter water, they become tsunami waves, which are just long, low waves that move across the ocean at incredible speeds, like up to 800 kilometers per hour. Now, you probably know what a tsunami looks like. Towering walls of water crashing onto land. That image comes from tsunami waves that hit shallow water near the coast and slow down. But out in the open ocean, tsunami waves are almost unnoticeable because their wavelengths are so long. For example, a wave with a 100-meter height might have a wavelength of 200 kilometers. That means the distance from the top of one wave to the next is 200 kilometers long. Meanwhile, the distance from the highest point of the wave to the rest of the sea is only 100 meters. So tsunami waves have long wavelengths, low heights, and really high energy. As seismic waves spread out from the earthquake, tsunami waves spread out from the point of origin in all directions. So if you're hanging out on the west coast of Mexico during a major earthquake, you should probably head inland. Why? Because chances are the tsunami is going to hit first. Now you might think seismic radiation would dissipate after passing through the Earth's core and emerging on the other side, but no way. As we mentioned earlier, seismic waves are partially reflected and refracted as they move from one type of rock to another. That includes when they hit the liquid outer core and get bounced back up into the mantle. These waves reflect and refract again as they pass through the crust on the other side of the planet. And depending on the angle of incidence, they might even bounce back towards the surface where they came from. That means an earthquake in, say, Chile might generate tsunami waves that circle the entire planet before making landfall somewhere in Asia. It's hard to predict exactly where and when these distant tsunami waves will hit, because they get modified by all the friction and variation in the ocean floor and coastline. But scientists have developed some models to try. For example, the inundation extent and timing for distant tsunamis can be estimated by assuming that the wave travels at a constant speed, determined by its wavelength and the depth of the water. Unfortunately, predicting where a megaquake will happen isn't quite that easy. Megaquakes are earthquakes with a magnitude of 9 or higher. To put that in perspective, a magnitude 2 earthquake is noticeable, but usually doesn't cause much damage. A magnitude 5 earthquake can be strong enough to damage buildings, and a magnitude 7 earthquake can level buildings and infrastructure. So a megaquake is like a bazillion times bigger than your average earthquake. Most megaquakes happen along subduction zones where one tectonic plate slides under another. The area around the Ring of Fire is particularly prone to them. In fact, 4 of the 5 largest earthquakes ever recorded happened there. To date, the largest earthquake ever recorded was a magnitude 9.6 megaquake that hit Chile in 1960. It generated a massive tsunami that killed dozens of people in Chile and Peru and even reached the Philippines 10 days later. Now, researchers use a variety of methods to study past megaquakes and model future ones, including analyzing historical records, studying geological evidence, and computer modeling. One technique that has gained popularity recently is paleoseismology, which involves digging up the land and carefully examining soil layers to identify the time and size of past earthquakes. By studying ancient fault lines, paleontologists can get an idea of how likely it is that an earthquake will happen again in the same place. This is important because the same faults are often responsible for multiple earthquakes over millions of years. For example, in the 1980s, researchers discovered a buried forest in the San Francisco Bay Area that had been leveled by an earthquake sometime before it was submerged. By radiocarbon dating the trees, the team found that the earthquake occurred around the year 14,000, and based on the amount of sediment above the buried forest, they knew the earthquake happened before the San Francisco Bay filled in. Other research indicates that the earthquake had a magnitude of around 7.3, which might not sound like much, considering the San Francisco earthquake of 1906 had a magnitude of 7.9. But the 14,000 earthquake was 10 times more powerful than the 1906 earthquake, and 1 million times more powerful than the 2011 Tohoku earthquake in Japan. And to put that in perspective, the 2011 earthquake and resulting tsunami caused between $10 and $15 billion in damages in Japan alone, let alone all the other countries that were affected. So you can see why it's important to understand how big megaquakes can get. Unfortunately, scientists aren't sure how big megaquakes can get. Most of the scientific consensus lies somewhere between a magnitude 9 and a magnitude 10. However, there's a lot of disagreement about whether or not anything bigger than a 9 can actually happen. Part of the reason is that there's not much evidence of megaquakes bigger than 9 on the geological record. Sure, there are a few fault lines that appear to have produced magnitude 9.6 earthquakes in the past, but we don't have much evidence of megaquakes above 9.6. One explanation for that is that the Earth's core prevents megaquakes from getting too big. According to this hypothesis, the Earth's core acts like a barrier that blocks seismic waves from traveling all the way through the planet. This would mean that the biggest megaquake that could ever happen is around a magnitude 9.6. Another explanation is that the strength of rocks varies from location to location, so the maximum size of an earthquake depends on where it happens. This is why researchers spend so much time studying specific fault lines. Each fault line is unique and tells us something different about the history of the Earth. So even though there's still a lot we don't know about megaquakes, we do know that they have the potential to cause catastrophic damage anywhere on Earth. That's why it's so important to keep tabs on potentially dangerous fault lines and study historical records to better understand the risks we face. We can also improve our early warning systems and create better building codes to reduce the impact of future earthquakes. Plus, we've come a long way in terms of earthquake detection. The United States has a network of around 3,000 local and regional seismic monitoring stations that detect earthquakes as they happen. The National Earthquake Information Center, or NEIC, gathers data from these stations and issues alerts within seconds of an earthquake happening. And thanks to the Shake Alert system, people in California can get an alert on their phone when strong ground motions are detected. This gives them enough time to drop, cover and hold on, or take other protective actions. If you live in an area that is prone to earthquakes, check in with your local government to see what kind of early warning system you have in place, and make sure you know what to do when the shaking starts. You might even want to consider installing a system that can automatically turn off gas appliances and prevent fires. While we may never be able to fully predict when a megaquake will happen, we can take steps to mitigate the damage they cause, and maybe someday we'll even find out how big megaquakes can really get. Thanks for watching this episode of SCI Show. If you would like to help support this channel, you can join our community on a crowdfunding platform.